All right, class, in this video I'll be doing the sixth example from section 8.2. It says find the exact value of the tangent of the inverse sine of negative 2/3. So the first thing we're going to do is we want to figure out what angle has a sine value of negative 2/3. And since negative 2/3 is, well, negative, that angle needs to be in quadrant 4. So I'm going to write out a sentence. If the inverse sine of negative 2/3 is equal to theta, then sine of theta is equal to negative 2/3. And if you look at quadrant 4 to find such angle, you're not going to find one because negative 2/3 is not a standard ratio on the unit circle. So we're going to need another method to find the exact value of this expression. So what I'm going to do is I'm going to draw a right triangle that would be located in quadrant 4. Theta will go in the top left. And the ratio for sine is opposite divided by hypotenuse. And the reason why the 2 is negative is because that vertical line is actually going down, which going down is a negative direction. We don't ever place the negative sign where the hypotenuse goes. That would be wrong. So we're going to leave the 3 positive and the 2 becomes the negative. And by applying Pythagorean theorem, this will be a positive square root of 5, and it's positive because that horizontal line is going to the right. So now we can figure out the exact value. So the tangent of the inverse sine of negative 2/3 equals the tangent of something. And if you go back to the sentence that I wrote, the inverse sine of negative 2/3 is equal to theta. So I can replace the inverse sine of negative 2/3 with a theta. Going back to the triangle that we drew, the tangent is the ratio of the opposite side divided by the adjacent side. So this ratio is negative 2 divided by the square root of 5. So the tangent of the inverse sine of negative 2/3 is equal to negative 2 divided by the square root of 5. And if you were to rationalize the denominator, that would be negative 2 times the square root of 5 divided by 5.